Okay, today we're diving into a real cosmic cold case. We're looking at this dense, ancient city of stars that's hiding a pretty big secret. I'm talking galactic collisions, evidence that completely contradicts itself. It's a mystery that has astronomers totally stumped, and we're going to see why.
So here it is. This is Messier 56, or M56 for short. You can find it in the constellation Lyra. Now, what you're looking at is called a globular cluster. Think of it like a giant spherical city, just jam-packed with hundreds of thousands of really, really old stars, all orbiting the center of our Milky Way as one big family. It's absolutely gorgeous, right? But it is incredibly far away.
So, just how far are we talking? Well, M56 is about 9.4 kiloparsecs away. Now, unless you're an astronomer, that probably doesn't mean much. So let's translate. That's about 32,900 light years from us. And to give you a real sense of that scale, the light you're seeing in that picture, it started its journey to us way back when our ancestors were literally living in the Stone Age. Just think about that for a second. Okay, so this is where the plot really thickens. For a long, long time, we all just figured M56 was, one of our own, a native-born star cluster of the Milky Way. But a pretty wild theory has popped up. What if M56 isn't from around here at all? What if it's an ancient immigrant, a refugee from a completely different galaxy? And that, right there, is the big question that's driving this whole investigation. The idea is that M56 wasn't born in the Milky Way. Instead, the theory goes, it was captured, snagged during a huge galactic collision that went down billions and billions of years ago. So who's the prime suspect in this galactic hit and run? Well, it's a former dwarf galaxy with a, let's just say, a memorable name, the Gaia sausage. Seriously, that's what astronomers call it. About 10 billion years ago, this smaller galaxy slammed into our Milky Way and got completely shredded and absorbed, leaving behind this trail of cosmic breadcrumbs, stars, and even entire star clusters all over the place. And here we have our first major clue. It turns out, when you track how M56 is moving through our galaxy, well, it moves like an outsider. It has the telltale kinematic signature, basically its flight path, its orbit, matches up perfectly with other known leftovers from that Gaia sausage collision. So, case closed, right? Not even a little bit. So, to really crack this case, scientists have to dig deeper. They need to follow the star trail, which means looking at the individual stars inside the cluster. And believe me, that is some seriously painstaking work. But there's a catch. See, when you point a telescope at M56, you're not just seeing M56. It's like trying to take a picture of one person in the middle of a massive crowd. You're looking through this thick curtain of other stars that are in front of it and behind it, so the absolute first step, before you can do anything else, is to figure out which stars are the real residents of M56 and which ones are just photobombing. So how on earth do they do that? Well, this is where the magic happens. What you're looking at is called a vector point diagram, and it's absolutely key. Using the super precise Gaia Space Telescope, astronomers can track what's called proper motion. That's the tiny, tiny drift of each star across the sky over time. And look, the stars that actually belong to M56, they're all moving together like a flock of birds. They form that dense blue blob right in the middle. All those other gray dots, they're just random stars passing by. And check this out. This shows you just how powerful that technique is. The gray dots represent all the stars in the area, plotted by color and brightness. It's a total mess, right? But once you use that motion data to filter out all the photobombers, boom, you get the clean, beautiful pattern of blue dots. That is the cluster's true family portrait. And now the real detective work can finally start. So now that they have a pure sample of M56's stars, astronomers can finally get down to business and analyze its properties. They were hoping for a slam dunk answer. But instead of clarity, they found something totally baffling. They found evidence that points in two completely opposite directions. And this is the heart of the entire mystery. Clue number one, the way it moves. That screams outsider, a refugee from the Gaia sausage galaxy. But clue number two, its actual character, the chemical makeup of its stars. It looks local. It looks like a native. It doesn't match the profile of the other immigrants. So how can both of these things be true at the same time?
To really get what's going on, we have to look at a very specific piece of evidence. It's called the Lie parameter, or just L for short. Now, this sounds complicated, but think of it this way. It's a number that basically describes the personality of the cluster based on how its stars are aging. It's like a unique fingerprint or a DNA signature. And for N56, that fingerprint number is 0.82. Just remember that number. Okay, and this right here, this is the smoking gun. This chart plots that L fingerprint we just talked about against something called metallicity, which is just the chemical composition. Now, the important part is that little triangular region down at the bottom. See it? Based on everything we know, clusters that are immigrants, the ones from places like the Gaia sausage, they should all land inside that triangle. So if our theory is right, M56 has got to be in there. But it isn't, not even close. Look where M56 is, that red dot, way, way up top. It is nowhere near the immigrant zone. The scientists who did this research put it pretty plainly in their paper. They said M56 falls well above this triangular region, making it difficult to support its possible extragalactic origin on this grounds. Basically, the DNA test came back and it is not a match.
So, where does that leave our investigation? We're stuck. We have two perfectly good pieces of evidence from two totally different methods, and they are telling us two completely opposite things. And honestly, this is what makes science so cool, right? It's not always about finding easy answers. Let's just quickly run through the case file again. On one hand, M56 is flying through our galaxy exactly like it's a refugee from that ancient merger. The motion is a perfect match. But on the other hand, its internal DNA, its stellar population, is all wrong. The charts that are supposed to ID the immigrants, they flag M56 as a local. It's a complete contradiction.
So what's the verdict? Well, there isn't one. The evidence points in completely different directions. The clues just don't add up. And so, for now, the cosmic cold case of Messier 56 has to remain open. It's just sitting there, waiting for the next clue, or maybe the next detective, to finally figure it out.
And that really is the question that just hangs in the air, isn't it? If M56 moves like an immigrant but doesn't look like one, then what on earth is it? Could it be from a totally different type of galaxy we just haven't even considered yet? Or maybe this means there's a chapter of our own Milky Way's history that we're completely missing. We just don't know. What is its story?